Imagine trying to repair a circuit without knowing its voltage, current, or resistance. It would be like fixing a car without being able to see the speedometer, fuel gauge, or warning lights. In this video, you'll learn about the multimeter, the most important measurement tool every electrical and RF engineer uses almost every day. A multimeter is a measurement instrument used to measure electrical quantities such as voltage, current, and resistance. It combines several measurement functions into a single device, making it one of the most versatile tools in electronics. Whether you are troubleshooting a circuit, testing a battery, or verifying component values, a multimeter is often the first tool engineers reach for. Modern multimeters are usually digital and display measured values directly on a screen. Older analog versions used moving needles, but digital multimeters provide higher accuracy, easier reading, and additional measurement functions. Many models can also measure continuity, diode characteristics, frequency, capacitance, and temperature. Because electrical quantities cannot be observed directly with the human eye, measurement tools are essential. A multimeter acts as a window into a circuit, allowing engineers to understand what is happening and verify whether a system is operating correctly. A multimeter works by connecting probes to points in a circuit and measuring electrical properties between those points. Depending on the selected mode, the internal circuitry performs different measurement operations and converts the results into values displayed on the screen. When measuring voltage, the multimeter compares electrical potential between 2 points. When measuring current, it becomes part of the current path, so it can determine how much charge is flowing through the circuit. When measuring resistance, it applies a small internal test signal and observes the response. Although these measurements seem simple from the outside, the instrument contains precision electronics that ensure accuracy and safety. Proper range selection and correct probe placement are important because incorrect connections can lead to inaccurate readings or equipment damage. Imagine a doctor checking a patient's health using instruments such as a thermometer, blood pressure monitor, and heart rate sensor. These tools provide information that cannot be determined accurately through observation alone. Engineers use measurement tools in a very similar way. A circuit may appear normal from the outside while containing hidden faults. A battery may look healthy but deliver insufficient voltage. A wire may appear connected but actually contain a break. Without measurements, diagnosing these problems becomes difficult and unreliable. The multimeter gives engineers objective data about what is happening inside a circuit. Instead of guessing, they can measure electrical quantities directly and make decisions based on facts rather than assumptions. In professional engineering environments, measurements form the foundation of design verification and troubleshooting. Engineers rarely assume a circuit is behaving correctly simply because it was designed correctly. Measurements are used to confirm actual performance against expectations. The multimeter is often the first diagnostic tool used during testing because it quickly reveals basic electrical conditions. Engineers verify supply voltages, check component values, measure current consumption, and test continuity before moving to more advanced instruments such as oscilloscopes or spectrum analyzers. In RF engineering, accurate measurements are especially important because even small electrical deviations can affect system performance. Although RF systems require specialized equipment, the multimeter remains an essential tool for power supply verification, hardware testing, and initial fault diagnosis. Suppose a communication device suddenly stops working. An engineer will often begin troubleshooting by checking the power supply voltage with a multimeter. If the voltage is missing or incorrect, the root cause may already be identified within minutes. Multimeters are also widely used for testing batteries, measuring resistor values, checking cable continuity, and verifying electrical connections. These tasks appear simple, but they prevent countless hours of unnecessary troubleshooting and component replacement. From hobby electronics to advanced RF laboratories, the multimeter remains one of the most frequently used instruments. Learning how to use it correctly is a fundamental skill that every electrical engineer develops early in their career. So today, we learned that the multimeter is one of the most important tools in electrical engineering, allowing engineers to measure voltage, current, resistance, and many other electrical quantities. It serves as the starting point for troubleshooting, testing, and verifying circuit behavior in both electronics and RF systems. In the next lesson, we'll complete this playlist with a summary video and bring together all the fundamental concepts we've learned so far. If you found this useful, like the video, subscribe, and follow for the next lesson.